Okay, so here we are, and I think we'll start part 2 with a look at the schematic of this Eddystone 840A that we're going to be working on. And looking through it, it's a very straightforward, basic design. Yes, it is transformerless, and it uses use paralleled and series heater circuits, which we already know. The tubes themselves actually seem to be working, so at this point I'm not worried about any of the actual valves. The rectifier also seems to be working, as I have run it from AC. So this section, the only concern I have is obviously the risk of electrocution on this set, and the fact that if you do run it AC, that the chassis can become live. To that end, I've decided to not power it up again until after I've done pretty much all the work on the set, and if nothing else for my own safety, what I will also do is I will power it up from an external DC power supply, and I've already got in my stock now, it arrived today, a 240 to 240 isolation transformer, but I've also got a 240 to 110 isolation transformer, both of sufficient rating to run this radio on DC. So I will build a dedicated DC power supply just for this radio, so that I don't basically destroy its intrinsically complete vintage. If I wanted to make it so that I could plug it straight into UK power supplies, what I would do is I would put in a UK kettle plug type receptacle. I'd ground the chassis out. I'd take out not so much the rectifier, but I might take out the multi-tap resistor if it wasn't needed, and put in my own DC power supply, so that it wouldn't be a transformerless design anymore. I have been reading around, and some people would say that would make the set infinitely less collectible. So I think I'm going to go with originality here. I'm not going to add bits that are not necessary. I'm not going to take away anything that, you know, wasn't there originally. All I'm going to do is I'm going to go through the start, and I'm going to look at things like these capacitors, anything that goes to the negative rail to start with, which is all of these non-polarized capacitors. And again, being AC/DC set, you can understand it being non-polarized, because it could end up, you know, being negative chassis or positive chassis, depending on which way on the AC you connected it. It doesn't make any distinction between hot line and cold line. So yeah, if this is the chassis line, if this is meant to be what you would call the neutral line here, which runs through as the valve filaments, then you've got to treat anything that connects to here effectively as a 0 volt DC, if you can possibly help it. Obviously, if you're going to connect this to DC, you would put your hot line through the switch. It would come through your large ballast resistor. It would run the heater here of your rectifier tube, and then obviously daisy chain its way through the heaters before going back to the 0 volt side. So you'd want, you know, hopefully to make this 0 volts DC and have your B plus, which comes out of here and through the choke, to be a straight DC circuit, and that hopefully would keep you fairly safe. As I say, if you look through the line, and I'm just taking resistor 2 here as an example. Resistor 2 comes in through here. It runs to the grids of this particular valve here, jumps over, goes to earth via a resistor, an R13. If I look at this thing here, R13 is a 47k ohm resistor, but it also jumps through C21. Well, C21, according to this, is a 0.1 microfarad tubular paper capacitor. Well, by now, maybe that capacitor is short circuit, which means you're getting B plus the resistance of R2 going, or B plus minus the resistance of R2, I should say, R2 being 22k as a load, coming to deck. And that's all it needs for you to be touching a live chassis. Not my cup of tea. After I showed you the 240 volts bit at the end of the previous video, like a fool, I forgot to switch the power supply off, and I grabbed both handles, and I screamed, and I dropped it on my toe, and that was the only thing that disconnected the crocodile leads out the back, and managed to release my muscles enough to let go of the set. So that's another reason for me not wanting to turn this thing on. So anyway, I've printed the schematic large, and I've actually got several copies, one of which I'm going to mark as per complete, another one I'm going to keep as, you know, completely unspoiled, so to speak, so that I can go through and know exactly what I've done and what exactly I've changed. So I'm going to put the radio on the bench, and the first thing I'm going to look at is from the input pins to the rectifier, and from the rectifier to the primary B plus line, which is this point here. And I think I'm going to go across. Obviously I'm not worried about the heater elements there, but I'm going to check the value of this resistor here. This is that tall resistor inside the unit that drops voltage. I'm going to check the value of this resistor and this R37 ballast resistor, and I'm also going to check C66, which is the first B plus filter capacitor, which goes straight to ground. And C66, according to this, is another 0.1 microfarad. C63 is 3 picofarads. It's C62, this one here, and C63 here, which are the big electrolytics, which again I'm going to look at, I'm going to test and see how they go. Enough of this waffling. We've done 10 minutes and I haven't even put the radio on the bench. So let me move this, let me get a radio, let's start measuring some things. Back shortly. Okay, so here we are. The first thing I've done, let me just make sure we're all focused in. What I've done is I've connected the negative probe of my meter, and it's purely on continuity, and you can hear it buzz. Shall I bring the meter in shot? I suppose, will it hurt, will it hurt, will it not hurt? There we go. It won't be as focused. And I'm sorry if it gets a bit dark, it's just that I'm covering up one of the lights with my head. So the first thing I'm going to do is make sure the set's switched off. Now the switch is on. So why am I going straight off this fuse? Well, this fuse connects to what says it's the negative input lead to the radio. Now I'm not interested in if the fuse is good. I know that this piece of wire is good, and I also know that it's not connecting to the chassis. It is actually insulated, although I've got to say the bolt itself is loose, so it is floating at the moment. I don't know if you can see that's floating. So what I'm actually doing is I'm just testing the switch arrangement and following the wire that comes out of the fuse, which is this white one, and we know that's good. Now we've got to just trace to where it goes. At the moment, with the off switch on, it's not touching any of these other connectors. So I switch the switch on, and let's see what this switch does. So there's the input. There's one output terminal. It's not on there. It's not on there, but it is on there, and that comes back on a black wire here. So that's the one we're going to follow through. Now there is another wire from there which actually goes to the frame of the potentiometer. So all I can say about that is I hope the potentiometer is insulated from the case, which it's not. So already I can see an issue with why the chassis is live. Regardless of all the extra insulation pieces, what you've got here is you've got AC potentially coming straight in and going straight onto the front panel. So not a good start, I don't think. So we've got to follow the black wire back, and that black wire comes back. I'm going to move that out of the way so I can see. Comes back, heads down here, and comes back to here, and comes straight to the voltage selector switch center pin. And I'm hoping I'm getting the connection there, and I'm not. I can't hear a buzz. So have I got the right black wire? That black wire. Yep, that black wire there. Now let's just check. Let's actually see if it's got a resistance, which might explain. Now that's saying it's open somewhere, so somewhere something is not behaving itself. I've got the switch open, yeah, and I've got the white wire. Yeah, let's go on the output, not that one, that one. Yep. Ah, no, I'm looking at the wrong wire, that's why. This wire then goes to the earth of the two filter capacitors here and here. So that is actually the negative side of the filter capacitors. So we know that that's got to be looked at. And that also goes, if I put it back onto connection, that also goes to the chassis, to the front panel of the knob next to the top, which is the RF gain control, which also connects straight to the chassis. So you have at the moment quite a situation with the front panel being live, and I'm not happy with that, I'll be honest. Yeah, I know we used to do things differently in the old days, and we were a little bit less safety conscious, but even now we weren't so badly let down by safety. So okay, so let's have a look then at the other fuse, because there are two fuses on the input. I'm gonna just undo that and go to the bottom fuse, and hopefully let's check the other pin. No, I'm not, of course it won't be there, it'll be because it's not live. Oh, there's no fuse in it. So yep, that one's live, and that comes in on the grey wire, which is here, and that goes to this black wire, which comes back to the voltage selector switch. Now at the moment it's set to 230 volts, so it comes to this red wire, so that's all good. And let's just check. Now that is not on the chassis at all. So the markings on the back of this radio actually had the top pin as positive and the bottom pin as negative. Now if you were going to do that with AC, that would mean your chassis is permanently live. So I will rip that sticker off completely, because you don't want a live chassis, you want the chassis at neutral. You don't want it hot. So anyway, getting back to there, black wire goes to there, voltage selector here, and that disappears onto, in this case, the red wire, which has the beads, which takes it all the way to the top of the 500 ohm resistor, which is multi-tapped depending on which voltage you're selecting. Now it's only beeping single bleep because it's actually measuring a resistance between the different taps on the resistor, as opposed to straight continuity. So the other end of that resistor is, if I remember rightly, not there. The other end of that resistor comes out. I'm going to have to refer to the diagram. R36 comes out back at the junction of R41. So R41 and then into R37. So R41, it says, is a 50 ohm 6 watt wire wound resistor. Now, okay, so we're back on track, and I've traced through, and we go from the output of the big multi-tap resistor, when I just untangle my my leads, and we come to the first fixed resistor, which is a 50 ohm resistor. And if I just connect to the wire wound resistor, if we're in shot and focused, 47.3 ohms. For that I'm not going to change it. And looking through the circuit diagram, the next thing we hit is this, what looks like a very burnt resistor, but it's actually a thermistor. And according to the manual, what you're meant to do is you're meant to read 15 volts across there when the set is running. So between there and there will be a 15 volt drop. Now I've tested it working, just using my hand heat, and it reads about 4K. As soon as I put my fingers on it, it starts to drop in resistance. So obviously it allows us a nice soft start, really. I think it's sort of so it doesn't bang straight in with full voltage. Although I can see a little bit of heat on this bit of Paxil in here. Nothing that I would say was totally damaged, and the heat hasn't reacted with this resistor here at all. Now, for some reason this resistor seems to have a couple of extra wires hanging out of it, but it reads correct, so I'm going to leave it alone. I think it might originally have been a plug-in device, and it's been converted to axial. I'd have to look, although those well-in resistors are pretty reliable. I've got some in my ham radio amplifier, and they are made very, very well. Can't see a date code on it, but I'm not looking for date codes, I'm looking for working. So from the thermistor we then go into the heater chain, which that's the ground side. Let's check this capacitor. And of course, what am I doing? I've taken all the valves out. There is absolutely no point in checking that part of it because there are no valves to provide heater continuity, because I got them all here. Just for example, here's the UY41 rectifier, and these are the mullards, but they also have the locking nodule in the side to prevent them working loose in their sockets. Quite a strange design, something you don't see every day, but there we go. So what I can do is, if I go between, and this is only a rough check, if I put this to the center of the capacitors, the center ground that is, and put that onto the capacitor itself, it's charging up, it's going down, and admittedly this is at low voltage. I could try the ESR meter on it and see what that gives us a reading of, but it is dropping down into the kilo ohms range, 42, 44 kilo ohms, 45, it's now going up. You know, we have had this powered, so by all accounts, if it's going to be good, it's good. If it's going to be bad, it's bad. From what I remember, we did have a hum. Let's see what the other one is like. Let's go to that one there. And again, 38, 39, 40k. They seem to all be charging up at the same time because they're in parallel. There's no direct short to ground, which I'm quite pleased with, which makes things a little bit better. But let's bring in the peak meter, and if we connect again, I'm going to just tilt you this way. If we connect to that center point, which is the earth point of the radio, and if I then connect to this point, Now it should see the pair of them in parallel to ground. If I can get it to stay on. And it's showing in circuit or leaky with an ESR of 0.64 ohms. Yes, it's in circuit, so I suppose the thing to do is to take them off, check them, and then decide if the initial capacitors are going to need restuffing, or whether I'm going to just put in some axial components and leave that part of the board so that the top looks original, but all the bits are on the bottom here and look more original. So let's get that done. If I take those capacitors out and we can test those, as I say, I'm going to go through this step by step. This is going to be a long series of videos because I'm going to do this right. There's no point in half doing the job, especially on a radio this old and possibly as rare as it could be. They only made the 840 between 1955 and 1961, and this is the A model, so it came in shortly after the original to give you the full slide rule glass on. Now I don't know how many were made. I think I read somewhere there were 6,000 sets sold worldwide. How many of them are still in existence, I wouldn't like to say, but if I can keep another one going, then all well and good. Obviously there's going to be a lot of checking done on this. There's going to be a lot of it's going to need to be a lot of getting it right and getting it to behave. I'll say it's not helped by the tightness of this construction, so here I am waffling about how hard it's going to be, whereas I should be getting on with it really. So I think the first thing to do is to pull those caps and see if they actually test as bad outside of the radio. Back in a moment. The leakage tester, and currently I've got it set to 200 volts, and the meter should kick up as the capacitor charges, and then as it drops down after about 8-10 seconds we should know whether the capacitor is still leaking. If it fails to drop, then I know that the capacitor still has leakage current coming through it. So here goes, let's hit the fire button. We could shout fire in the hold. What you must remember is I am not touching this case because I am about to shove 200 volts DC straight up its bum. And here we go, the capacitor charged. It is dropping down. And it's still dropping down. So now this capacitor is actually rated to 450 volts. So if I start to see much more coming through, I can actually turn it to the next level and see if it's going to stay at that sort of level. Now it's staying just above the 10 microamps mark, which could mean it's good. It's one of those things, it's not a lot of leakage, but it's enough leakage. If you're really going to be a purist, you should really say that no leakage is acceptable, but we have to live in the real world. That one in, I'll test the other one, and let's get back and see how we fare on that one. So all we have to do is make sure that everything that should be disconnected from it is disconnected from it. Now this one actually has a little bit of gunk flowing out the top by the looks of it, and there's only a couple of wires on it. So what I've got to do is get in there with the soldering iron. First of all, I'm going to release the meter, release the leakage meter. Oh, there was some charge in that. Yes, electricity can be dangerous, folks. So it didn't discharge fully. Oh dear, don't you love it? What I might do is I might just put my dead man stick across that and just make sure that she's gone. Yeah. And I'll do that to the other one as well, just in case she's retaining any sort of charge. Yeah, there's nothing there. Right, so so let's desolder that other one that's got the gunk flowing out of it. Mind you, that one's got the gunk flowing out of it as well. Oh, decisions. Do you just change them or what? Certainly you'd get one 50 mic in each of those cans, one of the modern 50 mics, so it can be done. It's not impossible. I wonder if I am, seeing as I am refurbing it, whether to just do it anyway and know that they're good. It's probably the better way to do it, isn't it? To know that they're good, rather than messing about. So this is where you got to be careful. There's one. So I don't want to melt any other wire, so I'm just using the pliers to grab the wire. You're going to have to excuse me if my big head gets in. I have all the respect in the world for the people who put these things together. Right, so that one's off now. So there's that one. It came from there, and the other one that came from the hole outside, which comes through the choke. So let me just put the tester on that one. Start with the positive one. If I can see down into the hole. Yeah, and that's not touching the chassis. And then I'm going to connect it to, I'm actually going to connect it to this ground here, because they are both connected together. Well, I'll connect it here at the ground where they're both connected together. Why go across the cap? Let's just do it to where it is there. And let's have a look at the leakage on the meter. Let's keep it in shot. Let's take the wiring off like that. Let's hit the fire button And again, that one kicks up quite high but drops reasonably quickly. Yeah, I could switch this meter to throw out 400 odd volts into that capacitor to see how leaky it is. I think 200's a good enough start. See, that one's actually dropping lower than the other one, so I'd say, you know, the first one is likely to be more leaky than the second one. But she is maintaining there, so yeah, not dropping much further. So that one's, I would say that one was less leaky. So I'm going to let it discharge through the meter and go there. So while that is discharging, I'm going to get my normal meter here, and we're going to check these other components to make sure that they're within tolerance. So the first one we're going to check is, I might as well put the probe to there, the negative to there, and let's first of all check this one. Now this, according to those bands, if I can read them correctly, is red, red, orange, so this should be 2, 2 with 3, so 220k at 10% for being silver, and it's 23.8k, so it's not too badly out of tolerance. Let me see, 10% of, okay, so let's just have another look at that resistor there, and that's reading, if I put that meter into shot, 50.6k, so well within the 4.7k tolerance of 47k, so I'm not particularly worried about that. Okay, so that's that one. Let's have a look what we got here. So that's reading 0.3 meg, so 300k, which when you look at the banding on it, so that is a 270k resistor. What do we say it was on the meter here? 300 and something k, so let's just go back to the meter. 302k, 27k, 10%, and it's reading 3. It's probably, again, it's just on tolerance. Just on tolerance. Yeah, if you've got 27,000 or 270,000, that leaves you 27,000 difference, which is almost 30,000. So 272, it's just in tolerance, yeah, for 10%. Okay, so that's that part of the power supply. I think I'm still going to remove those big caps. I think I am going to restuff them. So anyway, how long we've been waffling? We've been waffling quite a bit now, and we've checked a couple of capacitors and a few resistors. What I am thinking of doing to save any damage to the speaker and to give me better access is I think I will take the speaker out and not so much clean it up but keep it somewhere safe, just so that I can not damage it myself. That'd be the last thing I'd want to do, is actually have to replace a speaker. So with that, let's start unscrewing the speaker and have a look at what it looks like from the side without that there. Back in a moment. Okay, so here we have, I've taken the speaker out and it's got its codes on it, 6518 and 03721. Not being an expert on these things, I'm not gonna try and guess as to what it means, although knowing the age of the set, this could be the 16th week of 58, and this could be the factory. It does have the manufacturer's mark on it. It does have elec loudspeakers on there, and 619, is that 56 week 19? I'm not, as I say, I'm not an expert on this, and as you see, the paint is coming off of it. I've also noticed on the speaker itself that although the cone is intact, it's just starting to break up round the edges, so I might do the tissue paper repair with the PVA glue just to keep that in good condition, and at least working. As I say, we heard it play, we heard it sounds okay, so I'm not going to do anything crazy with that. So let's take that off the bench and store it somewhere safe. He says, trying to reach over to somewhere safe. And this is the view that you now get through the speaker hole. And I don't know whether I can get the camera to focus in on those two cans. Yes, I can. As you see, this one and this one, they both come in with 450 volt max working, 50 microfarads, and the date code on this one, February 1957. So for something that is let's dare I say 8 years older than I am, and you know, still in a radio, it's probably time to change it. So I think I'm just not, the fact that they seem to be okay at the moment doesn't mean to say they're always going to be okay. So I am going to take them out, I am going to change them, and to that effect, to keep the looks the same, I shall probably take the cans out, take the interiors out, and stuff them with a new 50 microfarad capacitor. Just as a sideline, that you can now see more into the set now that the speaker's gone. These are actually the bolts here that are holding the choke in, and these are the through hole feeders for the choke, which actually run between the capacitors. So you've got your first filter coming straight off the supply, going through a choke, and then coming out and then being filtered again. So it's adding in a second layer of filtering for it there. The choke still measures good, and again I can put the meter on there and I can still show continuity across the choke, and 137.7 ohms. It doesn't actually tell me on the schematic what the choke is. Let's just see if it's got a number on there. No, it just marks it as a choke. It doesn't actually even give it a designation on the circuit diagram. So, you know, it's a choke. It's probably whatever they had in the factory that would fit that can. Okay, so I wasn't actually quite so lucky when I unstuffed the capacitors. Getting them out the chassis, I managed to get one semi-complete ring and one that decided it was going to break in half. So what I'm going to do is mind the state of the bench. This isn't an operating table, this is the remnants of taking apart a radio. I've got the original cans here, and what I've done is I've taken the new capacitors, which are 47 microfarads, not 50, but 3 microfarads is not going to make much of a difference, and what I'm going to do is I'm going to use the original bases, and I'm going to put that so the positive line of the capacitor is through the base. I'm actually going to put it that way round because that's the flat side that was inside the can. What I've done to prepare the can is I've taken all the gunk out and washed it. Hot water, nothing else, just hot water, and then this is going to fit in there like that. Now it's going to clip in, and at the moment it's going to be loose, but what I will do is I will put a dab of glue on the base of the capacitor, or double-sided sticky tape. Although saying that, it's not going to move because the side is held on, and I am going to put the rubber ring back in, and I am going to crimp the ends back over. So in theory it should stay perfectly fine the way it is. So if I just pop that out again if I can, and of course there you go, I've popped it so well it won't pop. Shows how rigid these things are, doesn't it? Let's just see if I can grab both lines at the same time, and there we go. And as you see, in there. But what I will do before I actually reseal everything is I'm going to put on here, next to the thing, I'm actually going to put January 2018, and then I'm going to realise it's February. Oh dear, don't you just love it when you make cock-ups like that? What date is it? It's the 8th of February. Hey January, February. That was a song, wasn't it? January, you been... Yeah, if I sing it I'll probably get a copyright strike. So if we do Feb 2018, and always useful to have some on your bench, a little bit of solvent, and there goes one of the rings. That's that. Take that off, rewrite. February 2018. So that's that bit. So as I say, we'll take one of these. The centre goes through into the body like that. Then we put the capacitor into its shell, pop it in tight, and let's just make sure that that's pulled through as tight as it's going to come. That's it. That's right at the bottom. It's not going any further. Then just get the rubber ring, which I'm going to put on the outside of the capacitor. I don't want it on the inside for that. And then it's just a matter of rolling the frame. I'm going to do it with this complete one. The other one I'm going to have to modify, shall we say. I think that's the technical term. Just gently roll it over with the pliers, just to see if we can get it over like that. obviously you're trying to put some force down to trap the rubber ring as well, so that it does tension it. But when you do the final bit, which is tapping it with a hammer, it should stay as tight as it's ever going to be. So let's just roll that over. And it's a slow process, but you just roll it over and until the cap is pretty much as good as it was seal wise as when it was first manufactured ish. Maybe not quite that good, but hey, I don't have vast production lines of capacitor making equipment. There we go, using the existing remaining tab to force it on. And just bringing it round. Like that. And I'll keep doing that, and I'll do that for the other one. As I say, that one will be slightly different because of the broken ring. But let's find the other bits that can be pulled over. Like that. And then all I'm going to do is get a hammer and stand up while I get the hammer. Find one that isn't covered in wire, which in this workshop is a little bit difficult. And yeah, just an ordinary hammer, and just roll that bit over a bit more. Move the negative line up again, like that. So although it's rattling inside the cam, once this has got its lead soldered on, and this is actually taken to the negative, that will not look any different to the original part. So that's stuffing a capacitor. That's how I stuff a capacitor. If you've got better techniques, let me know. I'm always willing to learn. As I say, this is my first time with this type of radio. It's not the first time I've done this, and it was a technique I learned off YouTube. As I say, if you've got a better one, I could always put this on a piece of wood and then roll it at the sides, I suppose. That would make a bit of a difference. But that then keeps the original aesthetic, and I've still got one solder tag there which I can solder and crimp into the frame to hold it in position. Now obviously I'm going to have to do something a little bit more creative. I've got a solder tag here which needs to be made flat first, but rather than have you watch me trying all sorts of things to make a sealing ring, I'll come back to you when I've done this part and refitted the capacitors. Back soon. Okay, so the two caps are refitted down this side just off of sharp, and you'll notice I've taken out the two fuse holders that sit here. The reason for that is at this point here was a wax and paper cap. There's the fuse holder, one of them anyway. Where have I put that capacitor? It's not already got it in the bin, but yeah, anyway, there was a wax and paper capacitor, which there it is, I'm looking on the wrong side there, which actually connects from the B plus out of the valve to the anode of the valve. So you've got a capacitor straight across the cathode and anode, and I just took one look at that and I said, that's coming out. There's no issue about it. But unfortunately, because I'm a doofus, as I snipped the wire on the cap, I caught this wire on this yellow wire, which is the heater wire, and so I'm going to have to do a repair of that as well now. So to actually get into the base of the valve, which is here, to actually change the capacitor, I had to take the fuse holders out and disconnect the wires, both sides relating to both fuse holders, and that's only there just to make it easier for me. You know, I could strip the whole of this back panel down and take everything off and have it loose, but at the moment I'm trying to disturb as little as possible because I don't want to make any sort of future problems, if you know what I mean. It's just a case of trying to do everything so that it's as good as it was, rather than just, you know, hoping and praying that things go back the way they should. So anyway, what I'm going to do next is I'm going to take off this wire and this one, and I'm going to replace them with a new capacitor and do a repair. I don't know whether to repair this or just completely replace the wire. It's actually probably better if I do a repair with heat shrink sleeving, so that I don't disturb the valve socket, although I want to get a look in at that valve socket because I don't know whether there's some rust on the terminals or whether something is on the terminals. It doesn't quite look as clean as I'd like it to, so I'm going to get in there a little bit finer, which you can't do with the camera in the way, and have a clean up of that. So with that, I think I'm going to end this video at this point. It's quite a lot of footage for what seems to be not a lot of work, but I'm taking my time on this. I'm trying to do this as neatly and as efficiently as possible, so and without causing more damage. So with that, I'm going to say goodbye for now, and we'll see you in part 3. Links to part 1 will be at the end of the video, and you could also look at some of my other videos. Many thanks for watching, and we'll hope to see you in the next one. Bye for now.